Hello students, my name is Fizbo Hlachwayo, Umgungundlovu TVET College in the lovely province of KZN. Today we are doing NCV Level 3 Mathematics. Our topic is topic 4, which deals with data handling. Our subject outcome today will be to calculate and represent measures of central tendency and dispersion in univariate numerical and grouped data. Now, as in terms of our pre-knowledge and what we bring from level 2, we are reminded of the types of univariate data. And the word univariate, uni means one, and therefore it is data which is classified in one parameter. If we're talking about data from human beings, we could be using age as a variable. Therefore, it becomes, the age is univariate data. We also have bivariate data, which means we'll be looking at two variables. Again, if we're dealing with human beings, therefore we can look at their age and their gender. Then we can go on to multivariate data, which is multi means many, and therefore we'll be looking at more than two variables: age, gender, height, mass, and so on and so on. And this data can be ungrouped and grouped. And by ungrouped from level 2, you remember we said it is data that has not been exposed to n statistical analysis or n statistical arrangements. And if it is grouped, then some statistical processes, some grouping has been performed on the data. Then we also, at level 2, talked about measures of central tendency, which are the mean, sometimes also called the average, the mode, and the median. We also discussed the measures of dispersion, which includes the range, the lower quartile, the middle quartile or the median, the upper quartile, the interquartile range, and the percentiles. Now, in our first part, or in the first part of our lesson, we are going to work out the 5-number summary, or work out a 5-number summary. So most of the work that I'm going to be doing with you or teaching today, I'm just going to be showing you from the slides. But I would encourage you to have your calculators ready and a scrap paper next to you to do a little bit of calculation. Now, the 5-number summary, it represents a summary of the data set. So instead of talking about the whole data as raw as it is, we look at 5 main key areas that we can use to summarize the data set. So basically, we are looking at the lower quartile, Q1, middle quartile, Q2, and the upper quartile, Q3, as well as the minimum value, as well as the maximum value. Then the 5-number summary, therefore, is recorded as shown here in this particular order, with the minimum value starting, followed by Q1, then Q2, then Q3, and then the maximum value. And they are all bound in these brackets. Let's look at an example. 20 physical science learners achieved the following results out of 50. Work out the 5-number summary of the data. Now, this hint I am giving you, we have discussed this at level 2. When we get data, we need to arrange that data in ascending order. We cannot deal with data which is not arranged. In other words, it is these statistical calculations, they are position sensitive. So in this slide, I am showing you the data that has been arranged. And I've indicated X1, which is the first value. And I've put these dots and the arrow to represent that it starts from x1, the lowest or the smallest value, all the way up to the biggest value, 49, which is the 20th value. So, in essence, 1 is value number 1. 6 is value number 2. This 6 becomes value number 3, 4, 5, all the way up to 20. Now, the position of the lower quartile. We learned at level 2 that it is found using this formula. 1/4 times n plus 1. And the n represents the number of the terms in the data set. In this case, 20 is actually our n. If we use this formula to get Q1, the following calculation should be done. You can see here, I just changed 1/4 to 0.25. I changed this common fraction into a decimal fraction, but otherwise the calculation is exactly the same. Now, this 5.25 does not represent the lower quartile. It represents the position of the lower quartile. In other words, the position of the lower quartile is at 5.25th position in the arranged data. So if 1 is position 1, 6 is position 2, 6 is position 3, 7 is position 4, 7 is position 5. It means the lower quartile will exist between this 5th value and the 6th value, because between the 5th and the 6th value, that is where we will find this 5.25. So we need to remind ourselves that when we use this formula, we first identify the position of Q1. A similar calculation will be done to identify the position of the middle quartile, or Q2. And because it is in the middle, it constitutes the values or the value that is in the middle, halfway. Therefore, we use 1/2 times n plus 1. And the n still remains the number of terms in the data set. And this calculation comes in. Therefore, the position of Q2 will be between the 10th value and the 11th value. For Q3, a similar calculation will take place, and then we'll have 3/4 of n plus 1, and that value comes through. You can see now that in this data set, I have now identified the minimum value, and I've positioned Q1 between the value on position 5 and the value on position 6. I've positioned Q2 between the value on position 10 and position 11. I've positioned Q3 on the, between the value on position 15 and position 16. And my maximum value, which is the 20th term, is 49, as indicated here. In the next slide, I'm just showing you where, again, Q1 is, Q2 is, and Q3 is, so that we can then carry on with the calculation. Therefore, Q1. Now, you can see that to find Q1 now, we have to say the value on position 5 plus 0.25 of the space between the value on position 6 and the value on position 5. Now, where do we get this 0.25? You will remember in the previous slide, we said the position of Q1 is 5.25. 5.25 is found by adding 5 plus 0.25. This is where the 0.25 comes from. And then on position 5, we've got the value 7. On position 6, we've got the value 12. On position 5, we've got the value 7. After doing this substitution and punching this in our calculator, we will have 8.25. Therefore, Q1, the lower quartile, is 8.25. We move on to Q2. A similar calculation is performed there, and you can see that the value of Q2 is 18.25. 8.5. A similar calculation will be done for Q3, and the value for the upper quartile is 34. Let's move on. So now we have all the information that we want. In other words, the 5 summarizing numbers, we have them now on our arranged data. And therefore, the only last thing to do is just to present them in that fashion. That, as it appears, the minimum value is 1, Q1 is 8.25, Q2 is 18.5, and Q3 is 5.34. The maximum value is 49. I will then give you 2 minutes to determine the 5-number summary of this data that we have in this slide. I hope and trust that you were able to determine the 5-number summary of the data. I have already done the calculations for you, so let's see how it would display on our number line. So you can see on my solution, the data has already been arranged in ascending order. I've already indicated the minimum value, the Q1, Q2, Q3, and the maximum value. Then we can then summarize it in the same way, and then we indicate the values as we take them out of our number line. In this part of the lesson, which is the second part of the lesson, a continuation of what we've just been doing, we are going to be calculating the lower and the upper fence of given data. We are also going to identify outliers. Now, fences are a new concept that we are meeting at level 3. You will notice that at level 2, we never talked about fences. Now, fences are used as a method to check outliers. Again, the word outliers may come in as a new term. We will explain it very, very soon. We do have 2 fences, a lower fence and an upper fence. And as you will see as we continue, any values that lie below the lower fence or above the upper fence within the given data set are considered as outliers. So a basic definition here of outliers would be those values that lie either below the lower fence or above the upper fence within the given data set. They will be considered as outliers. To calculate the fences, we need the lower quartile, the upper quartile, and the interquartile range, which you will remember from level 2. Now, in this part of the lesson, we will continue to use the examples that we have used in the first or in the earlier part of the lesson. But this picture here explains what I've just, or shows what I've just explained earlier on. If this would be the lower fence, and this is the upper fence, or the position of the upper fence, on this range of data, then it means if there is any value from the minimum to the lower fence in this space, then that can be regarded as an outlier. On the other extreme, if you've got any value within the data set which falls above the upper fence, it can also be regarded as an outlier. In other words, the word outlier, it simply means it is lying way out of the fences that we have determined. The formula to calculate the lower fence is Q1 minus 1,5 multiplied by the interquartile range. And the upper fence would be Q3 plus 1,5 times the interquartile range. As I've said earlier on, our examples that we are going to deal with in this second part of the lesson will be referring to the examples and practice questions from the earlier part of the lesson. Now, from the first question, you remember we had the minimum value, Q1, Q2, I'm just skipping it for now because we don't need it to calculate or to determine the fences. Our Q3 is there. I also indicated the maximum value because they will help us. I have done the calculation for interquartile range, which you will know from our level 2, that is Q3 minus Q1, and that gives us 25,75. Then from this, we use the formulas that I've given you in the earlier slide, which is shown here right now. And then we calculate the lower fence and the upper fence. I will give you 2 minutes to calculate the lower fence and the upper fence using the given formula. Welcome back. So, as you can then see on my new slide here, I've used a thick red arrow to indicate the fences. And the lower fence, if you did your calculation correctly, you would have found minus 30,375. This is a negative value. It is much, much lower than the minimum value of 1, because you would have maybe 0 somewhere there and the negative values going all the way to the left. So minus 30,375, it falls way below the minimum value. On the other hand, our upper fence, it's 72,625. Again, it is way, way above the maximum value. Therefore, the lower and the upper fence, they are not found within the given data set. Therefore, in this data, we will not have any outliers, because the fences that we have determined here fall way below and way above the range of the data that we have. I'll then take you to practice question, which we did in the earlier part of the question, or of the lesson. We've done part A, which is to determine the 5-number summary, but now I want you to calculate the lower and the upper fence and state whether the outliers are present. In this case, I'll give you 2 minutes. I hope and trust you were able to determine the fences. Now let's go through the question once again. From the earlier part of the lesson, we did Q1, Q2, and Q3. And therefore now, we use Q3 and Q1 to determine the interquartile range, because we need the IQR for the calculation and determination of the fences. Now, for the lower fence, this would be our calculation. We do the substitution, we get 7,85. For the upper fence, a similar calculation, and we get 31,47. So 7,85 is the lower fence, and 31,47 is the upper fence. Going back to our data, which has been arranged in ascending order, you can see that 7,85 is a number or a value that is way below the minimum value of the data set. So on this side, we don't see an outlier. However, when we go to the other end, where we see the upper fence, you can see that 31,47 is the upper fence. And if we position 31,7 on the arranged data, you'll see that it will exist between 26,5 and 71,2. So this upper fence is still within the arranged data set. Therefore now, 71,2 lies way out or way above the upper fence. Therefore 71,2, which actually in this case is the maximum value, becomes an outlier. So an outlier is a value that lies a little bit way out of the general data that we have. Normally, an outlier is caused when there is an error in the capturing of data. I could argue here that probably the person was supposed to record 17,2, so they swapped the digits 7 and 1, and it became 71,2. So these things could happen, or an error in the capturing of data can cause these outliers. We have reached the end of our lesson, and therefore what have we covered in this lesson? In this lesson, we learned to present the 5-number summary, and then we learned that fences are used to check outliers, and that the values that lie below the lower fence or above the upper fence are referred to as outliers. In our next lesson, we are going to look at the construction of the box and whisker diagram. I want to take this opportunity to remind you that during this COVID-19 pandemic period, let's stay safe. Otherwise, until we meet again, peace.